First, we're asked to prove a trigonometric identity. It says equals, but actually this is true for all values of theta. Now, sometimes you want to start from the left-hand side and get to the right-hand side, sometimes vice versa. Sometimes it's good to maybe just have a little think about both. So I'm going to start with sine 2 theta, which is actually 2 sine theta cos theta. You can show that using the addition formula. I'm not going to do that here. This is just one you've got to know that that's what it is. Right, so I'm going to start now with the left-hand side. I'm going to try and get to 2 sine theta cos theta, then I'll know actually that is sine 2 theta. So left-hand side, okay. What can I do with this? Well, there's some trig identities. Sine squared plus cos squared is 1. We can quote that one. And there are some reciprocal trig identities that related to 1 and tan squared theta. So if I divide through by cos squared theta, I will actually get tan squared theta plus 1 is identical to 1 over cos squared theta, which is actually sec squared theta. So the left-hand side is going to become 2 tan theta over sec squared theta, which actually becomes 2 tan theta times cos squared theta, because sec, I didn't actually say this, did I? But sec theta is the same as 1 over cos theta. Well, that's the definition essentially, and hence 1 over sec theta is going to be cos theta, similar way. So that means 1 over sec squared theta is going to be cos squared theta. Okay, sorted. Right, we're nearly there actually. I'm going to now replace tan theta by sine theta over cos theta. Hey, and this is good because I'm dividing by cos theta. I've got this extra cos theta, so I've got 2 sine theta cos theta, which is sine 2 theta, which is the right-hand side. And that is enough. Now B, we're asked to solve an equation. It doesn't look very nice, does it? Note, we are working in radians. It doesn't say, but the angle range implies that, 0 to pi. Okay, first up, this thing here. Replace it by sine 2 theta. Okay. And now the classic way to deal with this, well, the way to deal with this is to divide by cos 2 theta. So it's going to become tan 2 theta equals 3. You've got a sine and a cos. You don't want that in the equation. It's always, you've got to try and get rid of it somehow, and we can by dividing. So, just now need to, if theta is between 0 and pi, then 2 theta is between 0 and 2 pi. So I'm actually going to find all the solutions for 2 theta. 2 theta is going to be inverse tan of 3. The calculator in radians, so I can just do inverse tan of 3, which gives 1.2490. Now, I like to solve these equations using the diagram. I don't like the cast diagram method or anything like that, so I'm going to go with that. Draw a graph of tan x. Now, technically, I'm actually drawing y equals tan 2 theta, but I'm plotting it y against 2 theta, so it just becomes a normal tan graph. You don't have to worry about tan 2 theta at all. Another way to think about it is we're doing a transformation, but I haven't actually done that in full. But you can this works, okay? Just trust me. So I've got a solution, and I've just actually found it here. For example, this one here, it's less than pi. So I want it between 0 and 2 pi. So the next one, I'm going to need to just add on pi, in fact. That'll give me another solution. which gives 4.3906. Okay, and then finally, to get theta, we just need to divide by 2. So I'll divide by 2 for the second one first, 2.1953. Or we had 1.2490 divided by 2, which gave 0.6245. Okay, so finally, three significant figures, and I'll write them in order: 0.625 or 2.20. So not too bad. I reckon the hardest bit was maybe that identity at the start. And then it was a case of substituting it in, being really careful. We need our answers between 0 and pi. Actually, I should just check. Yep, they're all between 0 and 3. And if you found the next one, it would go beyond it. One little trick you can do if you want is you could even substitute it, back in. So let's say we've got this one here. I can do 2 tan of the answer 1 plus tan of the answer squared. And I want to see if that's equal to 3 cos 2 theta. So in fact, I'm going to minus it and see if I get 0. Okay, so if I get 0, I'll be happy here, or something close to 0. And I do. This is a really small number, so I can be confident. Well, it doesn't take too long to check. You could check the other one as well if you wanted. But we are sorted. Well done.